All right, so I'm gonna actually start now. What, 11 persons online. So of course this is the first class. So in terms of the topic, the main topic is electricity. But before going into electricity, we definitely going to spend some time looking at energy and also in terms of conserving energy. As for this first slide there, actually showing you the image, showing you some examples of different kinds or different types of energy, where you're seeing light energy, heat energy, chemical energy, and of course electrical, which electricity will fall under, and definitely what is known as kinetic energy. So those are different examples in terms of types of energy. Irrespective of the type of energy, all energy basically have the ability to do work. Because in terms of the fire definitely going to burn. If you light the fire, the energy that comes from the fire is what will allow the food to cook. If you're boiling some water, if you're frying some meat or whatever, it is the energy that comes from the heat that allow those food to process. Energy makes things happen, and that is definitely so. Because if the time is dark and you should turn on the light switch, then what's gonna happen is that the place gonna be lit up in terms of getting brighter. So definitely, energy allow things to happen. So they are giving you some examples in terms of energy at work. That is the notes in ready. So heating of water. So definitely once heat is applied to a container, pot or anything metallic that contain water, then definitely it's gonna get hotter in terms of its temperature. Light electric lamp. So definitely electrical or electricity will the energy that comes from electricity will light up a lamp. Turning a bicycle, that is definitely the kinetic energy at work. When we walk or definitely when we talk. So those are examples in terms of energy at work, and energy at work definitely, as they are saying, will allow things to happen. So work is done when a force is applied to something and cause a change. So let's say for example you have a bucket on the ground or wherever you have a bucket or something just lying around. Once a force is applied to that object that you have lying around and the force is much higher than the weight of the object that is at that stationary position, then definitely it's gonna cause some form of change to happen, and definitely that change will be it, moving. So in terms of work, so they are saying that in order for work to be done, then a force must apply. For example, the image you're seeing, definitely this individual is using what we call a lawnmower. Now the lawnmower, whenever the lawnmower start, the engine does not push the lawnmower. That engine for the lawnmower just allow the blade to spin for you to cut the grass. So in order for the lawnmower to actually move from point A to point B, then you will have to be the one to generate that force. And that force should be heavier, that force should be more than the weight of the lawnmower, because that is the only way you will be able to push it around. So that's why first point I was saying that work is only done when a force is applied to something and cause a change. Because let's say for example somebody is not strong, a baby or somebody who is just not strong enough to push the lawnmower, then that person trying to use the lawnmower, nothing gonna happen because there was not a change, and that is definitely because that individual was not able to actually push the lawnmower around. So no change would have taken place there. Hence, no work would have been done. The change is mainly motion or movement, right? So motion or movement. So movement basically is talking about an object moving from point A to point B. That means that it physically move entirely. In terms of motion, it can mean that just a part of that particular object is being moved. So motion is whenever just a part of it is being moved. So let's say, for example, you apply some force to a container or anything, and it actually causes it to break or something like that. Then that would be known as a motion. But movement is when the entire object actually move from point A to point B. Work is done when force causes it to move. Right, so if you try to use that lawnmower and you're not able to move it from point A to point B, then definitely no work would have been done. Because let's say, for example, you're at home and your parents ask you to just using lawnmower again, ask you to cut the yard, and you is not strong enough to push it right around the lawn. Then once you're not strong enough, then no work will be done. So that's why that third point I was saying that work is done when force causes it to move. So if you're not able to move it, then no work will be done. And just about any thing you have within your environment that have some form of weight and you need to move it in order for you to carry out that particular duty. Once you cannot move it, change the position of it, then definitely no work will be done. If the force, whether push or pull, does not cause the object to move, no work is done on that object. And definitely that makes sense. So somebody can ask you to move an object, and when them come, they ask you if you're doing the work, and you're gonna tell them yes if you're not able to move that object. So the only way the work is done, and that is if the push and pull that you should apply to it, it causes the object to literally change. Once you would have accomplished or achieved that, then definitely you can consider work to be done. So in terms of looking at weight, so the object on the ground or wherever the object is, the only way you will be able to move that object is if the force that you're applying, whether pushing it or pulling it, is greater than the object itself. Once you can do that, then you'll be able to move that object. But if you cannot, then definitely that's it. No work will be considered done. Work also cause change in shape, right? And you're seeing on the image, so that person have those aluminum can, of course, Malta, Vita Malt, Pepsi come in those, Red Stripe beer come in those can, for example. So it is work is being done here simply because, as you can see, the shape of the container would have changed. So two ways you can consider work to be done. If you're able to move the object from its original position, and if you're able to change the position or the shape of the object, that is also an instant whenever work is being done. So I can ask you the question, explain or tell me when work is considered to be done in regards to an object. So the question again, when work is considered to be done in regards to an object, and definitely the two ways again, if you're one, if you're able to move the object from point A to point B, and two, if you're able to change the shape of the object. So for this example that you're seeing, it is the shape that is being changed. Let's say, for example, you have something that is, I'm going to use a block, for example. So a block As a baby, for example, a 1 year old baby definitely will have problem moving a block. So let's say, for example, somebody should give that 1 year old the task of allowing work to be done to that block, whether move the block or change the shape. Then that will be kind of difficult because a 1 year old, I mean, all they can manage its own weight. I mean, irrespective to manage the weight of a block. So moving the block, no, no. Changing the shape, that means that the baby would have to use something metallic or something heavy to break off a piece of the block. So that cannot be done, then no work will be done then. So example, they are saying crushing a metal can and definitely stretching elastic band. So when you have anything elastic in your hand and you're trying to stretch it, then that is work being done because you're changing the shape of the elastic band there. The energy transferred and work done are measured in a unit called joules. So just like how pounds or kilogram or gram is a unit that we use to measure the weight of an object. In order for you to measure in terms of energy, so the amount of energy that applied to an object to change its shape or change its position is measured in what is known as joules. Right, so forms of energy. So definitely there are different forms. Kinetic energy, abbreviation for it is KE. So this energy of motion. So this is an energy of motion. Motion definitely mean some form of movement, commonly called movement energy. So the fact that the energy is able to move from point A to point B, then it is definitely known as movement energy. Moving objects such as cars, bikes, bicycle, possesses this type of energy that is called kinetic energy. Right. So definitely, once something is moving in terms of an object, then I can apply. Then I can use that term saying that that is kinetic energy at work. Kinetic energy also appears as heat and sound energy. So, as for different movement taking place, more than one energy can be associated with that change in terms of position or movement. So, we have another one that is known as potential energy, and this is normally stored energy in an object because of its potential charge, but because of its potential change its shape and position. So looking at the bicycle there, as you can see, kinetic energy is the movement. So moving down and moving up. And they are saying that potential energy is at the top there, so stored. So the potential energy is stored. So the stationary book of potential energy. So if you have the book sitting down, that is potential energy. And the image that you are seeing, the bicycle is at the top of the hill there. Once it is not moving, then it have some stored energy. Or you can find out if it have some stored energy is simple because once the position is changed and you turn the bicycle down the hill, then it not gonna actually move. And that is simple because there would have been some stored energy there that is known as um, potential energy. So a book and a desk has the potential to fall to the ground if pushed over the desk. So that's why it is known as potential energy. And basically, almost everything that is stationary have what is called potential energy. if you have a ball on the ground, it has potential energy. Because once you apply some force, the ball not gonna start to move. So that is why the ball would have potential energy. So once something is sitting and lying around, it definitely have potential energy. Because if you should push it, apply a little force, then it definitely um, will be able to move from point A to point B. As the book falls to the ground, the potential energy is converted to kinetic energy. So that's the thing about energy. Energy can be converted from one form to another. So again, in terms of the ball, when the ball is there lying down, not moving, it has potential energy. But once you should apply some form of force, it now gonna actually convert from potential to kinetic energy. And because kinetic energy is all about movement, then that is why the ball will not be able to move, because the energy conversion basically change from the one that would be stationary, which would be the potential energy, and to the one that normally associate with movement or motion, which definitely is the kinetic energy. Electrical energy, electricity, definitely not a strange term to everybody, because you'll realize that we use electricity on a constant, on a regular, on a daily basis. So electrical energy, commonly called electricity. So electrical energy is carried by very tiny moving particles called electrons. The electrons are negatively charged particles. So this is energy at it work in terms of movement. Chemical energy stored in chemical structures of a substance. So the chemical energy is stored in the food we eat, right? So you will realize that you're able to move from point A to point B. You're able to move your body parts. You're also able to move object around, and all those requires energy. So you know our persons should be asking the question, how you get those energy? And definitely that would be from the food that you consume. So the energy stored in food and is stored in the food in a chemical format. So it is chemical energy. Because in food it definitely cannot be electrical energy, because you would not be able to benefit from it. So it's stored in a chemical format. After the food is digested, some of the energy is released, and definitely that is how you're able to move from point A to point B. So chemical energy definitely is a form of potential energy, because remember that potential energy is stored energy. So if they are saying that chemical energy normally stored in the food, once they attach that term stored to it, then definitely we now have to think of potential energy, because from the initial stage we would have mentioned that potential energy is definitely stored energy. So in terms of the examples of energy, definitely we have electrical, we have the chemical, and definitely we have the potential, and we have the kinetic. So you should be familiar, you should be able to list or tell me those different types of energy. And so we have two more here. We have nuclear and we have solar. So nuclear energy is normally stored in the nuclei of atoms. It is a form of potential energy. So that means that it is stored somewhere. Now, as for nuclear, we are not too familiar with it, and simply because, as the word nuclear suggests, there are some really dangerous chemical to it that can be harmful to human being. So these energy in terms of nuclear, this chemical, it is mostly used in weapons. At times you'll hear on the news Iran and all those places, they are in problem with other countries because they are building a type of weapon that is known as nuclear weapon. Now, nuclear energy, it is so powerful that just launching a nuclear bomb can literally flattens the entire island of Jamaica. That's how much potential energy um, that is located in nuclear. So nuclear really powerful. So it is so powerful that it is not commonly used. Solar, common energy, which definitely comes directly from the sun. So the sun gives out energy mainly in the form of heat and definitely light. All right. So as for heat energy, another energy that is not strange to anybody because on a daily basis again we use heat energy a whole lot. Whenever you hang some clothes on the line, heat energy help to dry the clothes. Whenever you're cooking, heat energy help to cook the food. So the energy pass from a hot object to a cooler object. That is heat energy. Hot objects molecules move faster than when they are cold. The great the greater the right, this should be the greater. The greater the kinetic energy, that's how it should be. Posed by the molecules of a substance, the higher its temperature. So in terms of heat energy normally makes object expand. And in terms of liquid, it normally make liquid evaporate. And perfect example in terms of evaporating, you will realize that if you should fill a pot in terms of cold water, cool water, and apply some heat, then it's gonna warm and then it become hot where it start to boil. Now, if you should allow the pot to boil for an extended period of time, you will realize that you constantly checking the pot, the water is getting less and less. And that is simply because heat generally suck up water, just that evaporate is the correct scientific term that we should be using. And that is why if the rain fall and this afternoon, tomorrow morning, tomorrow midday in the afternoon, you realize that you're hardly seeing any water on the ground. And that is simply because the water would have been evaporated um, due to the fact that the sunlight would be shining on the water. So that's a very important note briefly to understand that in terms of heat energy, it normally evaporates water. In terms of expanding objects, expanding once heat is applied, it can melt the object and it melt the object because of it is actually expanding the size, the particles of those smaller particles that make up that object. So again, in terms of the listing, and if I should ask you to list the different kinds, different types, we have more than enough if I should ask you to give me three. The kinetic, there, the potential, definitely electrical, which familiar with chemical, and as explain chemical saying that the food that we eat contain energy. So you purchasing a peanut, that peanut contain chemical energy and definitely potential energy. So it is so those are two stored format of energy. Sound energy, definitely the energy that carried through a material through which sounds travel. And definitely sound energy is transmitted by vibrating molecules. So anything that makes sound, yeah, there is always some form of vibration that is associated with that particular sound because it is only because of vibration while sound will take place. The greater the vibration, the louder the sound will be, and that's definitely true. If you're simple hitting against the wall. If you're using your hand and hitting the wall, you'll realize that the wall is shaking, it is vibrating. But if you hit it harder, definitely the vibration will be much more. And that is why whenever there's an earthquake, if the vibration is definitely not heavy, it is really slow, then you're not gonna feel the building shaking a whole lot, or you're not gonna hear any sound. But if the vibration is really, really, really high, then definitely you will hear a louder sound that comes from the building. Because whenever there is an earthquake, then the sound kind of unique. All right, so in terms of energy itself, that's definitely it. In terms of energy, as I would have said, we are literally looking at electricity, but definitely we have to spend some time looking at energy and the different types of energy. So again, for the persons who would have joined the class late, what is energy? It is definitely the ability to do work, and once energy is at work, then definitely something is happening. And we have the different examples. And work is done when a force is applied to something and cause a change. So cause a change mean that it is able to move. So you were able to move that object, then you can say that yes, work is definitely would have been done. All right, so that's it in terms of energy. I'm gonna bring up another PowerPoint looking at other aspect of electricity. Just gonna reshare the screen. Right, so we are looking at electricity and lighting. So everybody use electricity, so the term shouldn't be a surprise to anybody. All right, so once we're looking at electricity, these two terms must be mentioned because they are really responsible for the distribution and the read and not distributing electricity. So conductors are materials that allow electric current to pass through. So conductors mean that these objects definitely allow electricity to move from point A to point B. It allows it to move from one object to another. So these are known as conductors. So materials. So the image that you're seeing there, of course, they are showing a wire of different colors. So now the material that make these wires that you're seeing is known as copper. So copper and aluminum are excellent conductors of electricity. What do we mean whenever we said that copper and aluminum are excellent conductors of electricity? It definitely means that these two materials can allow electricity to move efficiently from one place to another. That's what they mean. So a piece of rope, a piece of plastic bag, a piece of rubber, you definitely cannot say that those are good conductors of electricity. And that is simply because those materials don't allow electricity to pass through them. So they are known as insulators. So we need to know the difference between conductor and insulator as it relates to electricity. So guess what? Anything metallic, you would consider them to be conductors of electricity. So if you should um, use a piece of steel to touch a live wire mean that it has electricity in it or it have current in it. So if you should touch one end of the steel and that live wire, and then you touch the other end of the steel, then definitely you will get some form of electric shock. And that is simply because the steel, it is metallic, hence it will allow electricity to go through it. So anything that is metallic, any material that is metallic would be considered to be conductors. It is just that we have good conductors and we have poor conductors. So we have some objects, yes, they can allow electricity to go through them, but not a lot of electricity. That is why I would say that those are poor conductors. While the good conductors, it all depends on the material. Because the second pointer is telling you definitely that copper and aluminum, those two materials, they are known as good conductors of electricity. And that is why once you're dealing with electricity, then the wire that you're seeing, those are made of copper. So the copper kind of always have this reddish or this brownish appearance. So those electrical wires that you're seeing, those are coppers. As for aluminum, a perfect example of aluminum would be the wire that JPS use to run their electricity, whether from their post to your house or the electric the JPS line that you're seeing that run along the road, those are copper. And if you realize not copper, those are actually aluminum. So an aluminum in general have a silverish appearance. Copper in general normally have that brownish appearance. But both of them definitely are excellent conductors of heat. It is just that for different purpose you will need to use copper versus you using the aluminum. But in general, aluminum they are normally lighter in terms of weight, and copper definitely would be of more heavier weight in terms of their heaviness. These are normally used to make electric wires. So definitely most of the electric wires within your house they are copper, and aluminum definitely are used on a much wider scale in terms of JPS or any electrical power company, because one, using so much wire, you would want to use a material that is extremely light, and and that is why they would have gone the route in terms of using aluminum rather than using copper. So within your environment, you definitely should be able to differentiate between things. Tell and definitely look around, and you should be able to tell me what are the things that are conductors within your environment versus the things that are insulators in your environment. Now let's look at this JPS line that they are showing there. Now you will realize that the wire that normally transport the electricity at the point at which they are being attached to the light post itself, you'll realize that you are seeing other objects. So those objects that literally attach to the light post, those are definitely will not allow electricity to pass through. Because if the light post is wet, then it can cause serious problem in terms of electrocuting persons within the environment. Now, electricity. Now, these materials do not allow electrical current to pass through them, and that is insulator. So down the bottom, you will see different examples. So just like how you have examples of material that are called conductors, we have examples of material that are called insulator. So as for insulator, these materials, these things does not allow electricity to pass through them. Rubber, by now everybody should know that rubber will not allow electricity. Plastic, and we have paper, and we have glass. In terms of wood, you will realize that them point it out for you. Then say dry wood, right? So that is simple because let's say for example you're using bamboo. If the bamboo is wet and you're using the bamboo to put up some electrical line on the JPS power grid, then definitely if the bamboo is wet, you can be electrocuted because you're actually using a wet bamboo. So that's why I then said that the wood should be dry. So you're being asked to list or give some things within your environment, that those things they are known as good insulators, are there poor conductors of electricity. Then you can use some those from the list there: rubber, plastic, dry wood, paper, and definitely glass. All right, so after looking at electricity in that light, the next thing is now to look at what is known as electric circuits. So we are now talking about energy now being able to move around, move from one point to another, and allowing some form of work to take place, like what you're seeing on the screen there. So a circuit. So in order for an electric circuit to flow, so we're talking about electricity. In order for the electricity to actually flow or move around, there must be a complete path around which the electrons can travel. So it is within the electrons that the energy normally travel. So there should be a path. There should be like a roadmap. So here on the image we have a battery. So the battery is that yellow object to your left, and definitely we have some connectors. As for the switch form a very important function, because by right the energy is supposed to go around in that circle, but if the switch is turned off, then the energy definitely will not go around. So as you can see in terms of attachment, you have the red or whatever color you're attached to one side of the bulb, then and then you have this yellow one attached to the switch, and the switch eventually attached to the battery there. Now the switch normally built in such a way where when you click it to the on position, it allows two metallic strip to touch each other. Once they touch each other, that's when the circuit is closed. And once the circuit is closed, that is how the bulb will light up, for example. So we're seeing the bulb there, the blue base section and the bulb at the top there. One of the cable is attached directly to the power source, which is the battery. And the yellow cable, you're seeing that one end is attached to the bulb there. And going forward, looking at it, you'll realize that there's a switch. So the cable come on attached to one end of the switch, and the next piece of cable that is attached directly um, to the battery will actually come to another section of the switch. So the only way electricity can pass through the switch so that the bulb can light up is if the switch is turned on, and in the on position, that's when um, both ends will touch each other and allow the electric current to pass through. All right. So an electric circuit needs some different things. One, it will need the electric source, such as a battery, a cell, or mains electricity. So in order for you to have a circuit, meaning that in order for you to have electricity moving around within a particular pattern, let's say for example a circle, there must be an energy source. So you can't be providing energy, you can't be charging you can't want to charge your phone and you don't have any energy, whether it is stored. So the stored would be if you're using a power bank, and definitely if you can get a JPS outlet and you get a charger, plug it in it. So there must be a source in terms of the energy. An appliance such as a lamp or TV, so you need to have something to suck the energy, to utilize the energy. So the image that you're seeing, what is utilizing the energy would be the bulb, and what would be the source of the energy would be the battery. So connecting wire to link the different components in the circuit and provide a complete path for the electricity. So definitely moving the energy around within the circuit, you have to be connecting wires. I say if you want to link different component within the household to work from JPS power supply, then definitely you'd have to connect different wires. Whether you're gonna plug them in directly or you're gonna find some form of way. The energy available to drive the electrons. Julian, just joining in. Alright, so the energy available to drive the electrons around the circuit is referred to as voltage. So the voltage can high and the voltage can low. So in order for the electrons to basically move around, then what is known as voltage is needed. So if the voltage is high, then the current are going much stronger and the current are going to move much faster. If the voltage is low, then that simply means that the electrons will take a longer time to move. And once they cannot move fast enough, then definitely they will not provide any energy. Most circuits contain a switch to regulate the flow of electric current. So the switch is very important, because if there is not a switch, then the object would be just using the energy continuously even when they don't need to use it. So that's why the switch is very important. So the switch allow you to make some form of control, and definitely need to control with electricity, because if it is not being controlled, then you're just gonna have to pay how much you would have been using. So it need a switch. When the switch is closed, so the bulb will light up. So what we mean whenever a switch is closed is that the one that we're looking at now, this piece of cable that comes from the battery and the other piece of cable that comes from the bulb, they are not touching each other, because if the switch is on the off position, then they are not touching each other. But when the switch is turned on, then both ends will now actually touch each other, and that's when the bulb will light up, and that's when the circuit will be closed. So when you hear somebody mention a closed circuit, they mean that the electric current is going right around. Because if you look at the image, if one end connect to it there and then it go around at the circle, but the switch sometimes will be open and sometimes it will be closed, meaning sometimes it will be off and sometimes it will be on. Once you click the switch to turn it off, then the circuit is open. But once you click to turn it on and the bulb no light up, then you now say that the circuit is actually closed. Alright, so when the switch is open, so and that is the off position, then you would say that the circuit would have been broken. This prevent the flow of current through the circuit, because there are times whenever you just don't want any flow of current and you don't want any flow of current, then definitely all you need to do is leave it open. But if you want a flow of current, then you close the circuit and definitely turn it on. So of course there are types of circuits. We have series circuit and we have another one that is called parallel circuit. Now when you look at those light bulbs, you'll realize that they line up behind each other. So it's like they are sequentially put out. So that is what is known as series circuit in terms of how you connect these bulbs. All components are connected together in one loop. The current travels through only one route. So What you're seeing is that there is this electrical cable. So looking at the two blue wires that come from the electrical cable. Now notice one of the wire come down there. It go to this end of the bulb, and then there's another wire at this end of the bulb that connect this bulb together, and this bulb is connected this one with this wire design or combination. Now, if you look at the end there, there's a blue wire that goes all the way to the source that plug into the wall. And of course, this one that comes from it, it is just that it branch out to a different one. So this is series. So this is so the fact. So as for this first bulb, how it get to light up is that the electricity that is coming from this cable at the end there, along with the energy that is coming from this bulb right there. As this cable that go down there, it literally carry energy that direction, while this one carry energy that the opposite direction. So all the components are connected together in the loop. The current travel through only one route. So one route the current only travel. Alright, so if one of the components become defective or disconnect, no electricity current fill will pass through the, if that should be will. Now I don't know how many persons know paper light, and I don't know how many persons know paper light, and they will notice that as for the paper light, if you should remove one of the light, sometime the rest of the paper light not going to work. It definitely not going to work, and that is because it is connected in that format. It is connected in a series format, and once it is connected in that series format, then definitely you will not able to get the light from it because they are in series. So here we have another example. The top one is representing bulbs being connected in a series format versus the bottom one where the bulbs are being connected in what is known as parallel format. So as you can see for the series, the black cable at the top there just go through continuously, and then you're seeing this red cable, so you connect from that bulb to another. So this is known as series. So if you should remove one of these bulbs, then there will be no continuity in terms of electricity because you remove one of them. Because if the current normally travel in that series sequence, means say move from one step to another, or it move from one object to another, then the fact that one of the object will is removed will simply mean that, I mean, that's it, not gonna get any more energy until it is being replaced there. Now, as for parallel energy, definitely completely different in terms of how the components are connected. So parallel meaning that they are side by side. So you're seeing these two bulbs. The two bulbs then definitely connect to the source, so they don't connect to each other. They all connect to the source. So in a parallel circuit, there is more than one route through which current can travel around and back to the battery. So more than one. So as you can see, as for right there, the both bulbs eventually connect to it. So at this over to the left hand side there again, um, both bulb definitely connect to that one. The current normally splits up to supply each branch of the circuit with electricity. So there's a separation. So there's no continuous series, which means if one remove, then definitely you're not going to get enough light for the other. A defective or disconnect component in one part will not stop the flow of current to the remaining um, branches within that particular circuit. So, as for electricity, there are some symbols that we need to be aware of. I'm gonna down down here for A and B. There are some symbols there, and you might not be familiar with those symbols under the symbol because I wouldn't have provide you with them. But I'm gonna send you the symbols as in what they mean. Just give me a moment. Let us send you the symbols. So we have A, we have a series circuit there, and for the B, we have a parallel circuit there. So down the bottom we have it labeled as A and B. Down process, once you get this symbol, then you should be able to literally put the label in there. Right, so I just send it in the WhatsApp group. Reshare this. Right, so for example, we have this section there as for A. We are seeing that this line, it is moving away from that dot. Now, when you look at the image that I would have sent you in the WhatsApp, you can tell me what that symbol, which component that fits. Can anybody check the WhatsApp and look at the image in the WhatsApp and can tell me which component this section fit, where you're seeing this line moving away from the dot? So I send a table where you have component, you have the symbol, and you have the notes that come with it. Now, so this represent what is known as the switch. So if you should check the image in the WhatsApp, it represents the switch. Or I can just share it on my screen so you can see it. Right, so looking at the screen, you can see that this represents the switch, so it is labeled as the switch. So once you're looking at circuit, then you should be able to give the name of those symbols, what they do, what they represent. So all of these symbols that you're seeing here, and the PowerPoint where you have the series circuit and you have the parallel circuit, then what you're going to do now, you're going to actually literally draw these, or I don't know if you want to take a picture of them, but as for them, you're going to label the circuit, label what and what the different things are. Because as I said, as for A, this is the switch. So you're going to label that section of the switch. Up here where you have this section, you're going to label it based on that image that I would have sent in the WhatsApp. And down here, you also need to label these two based on what they look like, that what I would have said. And you're going to do the same thing for B there. You're going to do the same thing over the B section.